Alright, welcome back everybody. In this video we're going to look at the first few examples from the Substitution Part 1 lesson. First we introduce you to the concept of integration by substitution. What we're doing when we use integration by substitution is we're taking an integral that looks complicated and we're going to make it easier by making a substitution to replace a portion of the integral with another variable. And our goal in doing this is to turn it into an integral that we can find by just using simple anti-differentiation. So basically, if you look at the substitution rule down here, what we're doing is we're taking the integral f of g of x times g prime of x. We're going to replace g of x here with a single variable u. And then we're going to replace, since u is g of x, du is going to be g prime of x dx, and we're going to replace that with du. And that's the basic idea. Now, as we get into some more complicated examples, we'll see some different things, but today we're going to start with some relatively simple examples, and I'm even going to keep the training wheels on, so to speak, where we're going to tell you what the substitution is that you're going to make. So let's go ahead and we'll look at example 1. We're going to find the integral of 3x squared times the sine of the quantity x cubed plus 5 dx using the substitution that u is equal to x to the third plus 5. This is a very simple one for us to start. Notice the substitution that we made, the x cubed plus 5, is something that is inside of another function. In this case, it's the quantity that's inside the sine function. So let's take a look at how substitution usually works. We'll write down our substitution. And then we'll find the derivative of that with respect to x. So this is going to be the derivative of u. And if I take the derivative of the right-hand side here, I get 3x squared dx. And now we're going to make our actual substitution and set this up to integrate. First of all, we're going to replace this highlighted portion with a u. And so that's going to be the sine of u. It takes care of that whole piece there. Now notice everything else in here, we've got a 3x squared and a dx. That is exactly what is equal to du. So we're going to replace that with the du. And by making the substitution u equals x to the third plus 5, we've changed this integral into the integral of the sine of u du. This is one that we can find by basic anti-differentiation, so we're going to go ahead and do that. The antiderivative of sine of u is negative cosine of u plus a constant. And now all I need to do is bring u back into this, and I have my integral for the original function. And that right there is the function that when I take the derivative of it gives me my original integrand. Okay? And there we found our indefinite integral. Alright, let's move on to example 2. So it's going to be a little tougher. Again, notice that we've chosen the substitution. We've taken what's inside of this quantity being raised to the power, and that's what we've chosen as our substitution. So the first thing we're going to do is take that substitution that we've chosen and write it down. And then we're going to take the derivative of it. The derivative of u is equal to, and on the right-hand side, we get 4x dx. Okay, so this is a little bit different from the one that we had before. What's left when I make the substitution of u is I have 48x dx remaining behind. And I need to replace that with what it's equal to in terms of du. In the first example, it was exactly what our du was, so it was an easy replacement. Here, a little bit more difficult. what we need to figure out is we need to figure out what's equal to 48x dx. And we're going to use what we already have down here, that du is equal to 4x dx. Well, in order to turn this 4x dx into a 48x dx, which is what I need to replace, I'm just going to multiply both sides of this equation by 12. And so I'm going to replace the 48x dx with a 12 du. And so when I'm done doing all that, I've got 12 u squared du. All right, make sure you process exactly what happened with that replacement there. And now I can take the integral of this by simple antidifferentiation. Honestly, I would probably remove the 12 from the integral and just think about it this way, since it's a constant multiple. So we've got 12 times 1/3 u to the third plus c. And so that's going to give us 4u to the third plus c. Notice here I didn't need to change the c. I didn't need to write 12c because all this is a constant that we don't know. So when we multiply it by 12, it's still just a constant that we don't know. And now we're going to bring u back. U was equal to 2x squared minus 1. And so there's the integral of 48x times the quantity 2x squared minus 1 to the second dx. All right, one more example on this video. Let's go ahead and we'll do example 3. We're going to find the integral of sine of x times the sine of the quantity cosine of x dx. Using the substitution u equals cosine of x. Again, notice that the substitution that we chose is something that's inside of another function. And so we're going to write our substitution down. And if u is equal to cosine of x, then du is equal to negative sine of x dx. Just take the derivative of both sides. So we're going to take this piece and just replace cosine of x with u and leave the sine, since that's the function that is operating on the cosine of x. So that's going to turn into the sine of u. And then we need to replace everything else with some expression in terms of du. So we're trying to replace the sine of x dx. Du is equal to negative sine of x dx. So that means that we're going to replace the sine of x dx with the opposite of du. And so this turns into the integral of the opposite of sine of u du. Now I'm going to find that by antidifferentiation, and that's just going to be the cosine of u plus c. And so my integral is going to be the cosine of the cosine of x plus c when I bring u back. And there's my integral. All right, that's it for this video. We'll come back next time and look at examples 4 through 6. Hope you have a great rest of your day. See you next time.